Alright everyone, so welcome back. I wanted to post the second video with mainly some examples of factoring for you to watch as a guide while you go through things. So let's start with another example, alright? And let's make this one maybe just a little bit trickier, alright? So let's try, what are we thinking? Let's try m squared. Let's try m squared plus m minus 90, okay? So right off the bat, you see this number 90. What are we going to do with a 90, right? So we know, first off though, we know that our factors are going to be m plus or minus some number times m plus or minus some other number, all right? We also know that we're multiplying two numbers together to give me a negative, but they add to be a positive. So the only way to get a negative here is if one is positive and one is negative, okay? So think about the term 90. Is there anything that multiplies to give you 90 but adds to give you 1? All right? So the first thing that I think of is actually, what about 9 times 10, right? I know the difference between 9 and 10 is 1. I know that 9 times 10 is 90, so that should work. But I need the 1 to be positive. So that means I need the bigger number to be positive, okay? So that means I'm going to do this as m plus 10 and m minus 9, okay? We check our work. 10 times negative 9 gives me negative 90, and 10 minus 9 gives me positive 1, okay? So now let's do the same thing using the box method. All right? So remember that in our upper left corner, we put our first term, and in the lower right corner, we put our last term. Okay, so I'm going to put m squared here. All right, and in the bottom corner, I'm going to put negative 90. Okay, I multiply these two together. M squared and negative 90 gives me negative 90 squared. So I'm looking for something that multiplies to give me negative 90 and adds to give me plus m. All right, so what two things multiply to give me negative 90? We've already done our practice with figuring out what our numbers are. So let's try that first. We've got negative 90, so I know it must be something like 10 and 9. So I know also that that's going to have to be positive and negative. So we can go ahead and put that down here. We can put 10m and 9m. All right, we can check our work to make sure. We already know that there has to be one negative, but we can try anyway. 10 times m is positive 90, okay? 10 times 9m. So that gives us positive 90. Oh, excuse me, this should be m squared. All right, positive 90m squared. I know it needs to be negative. I also know that my number over here needs to be positive. If that number needs to be positive, then you are going to have to make the bigger number positive. So this should be positive, this should be negative. All right, now we write out our factors. I know there should be an m here and an m here because m times m gives you m squared. What times m gives you negative 9n would be m minus 9. What times m gives you 10m should be plus 10. So these are our two factors, m plus 10 and m minus 9. All right, let's go through a couple tricks here though. Okay, notice how I've been putting, these positives and negatives. Anytime, all right, so anytime you have an expression like ax squared plus or minus bx minus c, anytime you have this form, you know your factors are going to be x plus some number times x minus some number. How you tell which of the numbers is positive and which is negative is by this sign here. If the number in front of the b is negative, all right, so if the number in front of b is negative, you know that the bigger number needs to be negative. If the number in front of the b is positive, you know that the number in front of that b needs, or in front over here the bigger number needs to be positive. Okay, that's just kind of a trick that I've found when I'm working with problems like this, just to make it a little easier. Now, with factoring, the hardest part, guys, the hardest part of factoring is figuring out what multiplies by what and adds by what. A lot of the times it's a puzzle. And sometimes it helps just by going through all the factors of that given number. Okay? So for example, with 90, the only factor that jumped into my head right off the bat was 9 times 10. Okay, that's the easiest factor and actually works in this situation. I also know that 9 is divisible by 5, all right? But I also know that 5 times something to equal 90 is not going to give me 1, so I can discount that, okay? So go through your factors for C step by step and check each one if there's any combination that adds to BB. That's basically the process of factoring, guys, and I know it can be tricky, but the more you practice and the more you get to know those timetables and the more you get to know how to put that puzzle together, the easier this will become. So hopefully through practice and practice and practice, you guys are going to find that this becomes easier and easier. All right? I'll go through one more example, and I'm going to do this one simply in my method. So let's go with n squared. Actually, no, we already did that one. So let's go with, we'll do this one. N squared minus 10n plus 9. All right? Now, I've got a plus over here, but I have a negative over here. Now, this is another great example. If you ever have a plus in front of the C and a negative in front of B, you know your factors are going to be like such. N minus some number times n minus some number. Because the only way to give you a positive multiplication but a negative addition is if both numbers are negative. All right? So what two numbers multiply to be equal to 9? All right, first thing that comes to my mind when I think of 9, I think of 3 times 3. Negative 3 times negative 3 is going to give me 9. But negative 3 plus negative 3 gives me negative 6, so that doesn't work. So what about 9 times 1? All right, negative 9 times negative 1 gives me negative 9, plus 9, excuse me. And negative 9 plus negative 1 gives me negative 10. So there we go. So it should be n minus 9 and n minus 1. All right, now, this last thing I wanted to go over before I cut off this video, guys, is what happens if you're given a situation like this. X squared minus 16. And you're asked to factor this. All right? This is a very special case of quadratic factoring where you actually have a perfect square over here. If you're ever given something that's of the form x squared minus a, where a is defined as a perfect square. By perfect square, I mean it's like 9, 16, 4. It's 3 times 3. It's the same number times the same number. All right? If you're ever given this situation, simply determine what the square root of 16 is. So the square root of 16 would be 4. And your factors are going to be x plus 4 times x minus 4. All right? This happens because when you multiply 4 times negative 4, you get negative 16. But when you add 4 plus negative 4, you get 0. Okay? So this is what we call a perfect square factor. And all you do is if you're ever given this format, so perfect squares right off the top of my head is if it's x squared minus 1, x squared minus 4, x squared minus 9, x squared minus 16, x squared minus 25, x squared minus 36. You could keep going, obviously, to 49, 64, and so on and so forth. But for our situation, these should give you the idea. So for x squared minus 1, it would be x plus 1 and x minus 1. X squared minus 4, square root of 4 is 2, x plus 2, x minus 2. X squared minus 9, x plus 3, x minus 3. So you guys kind of get that idea, I hope. So throughout this lesson, we've learned a lot of different types of factoring for a equals 1. Like I said, the hardest part is going to be putting that puzzle together and figuring out what two numbers multiply to give you C, but add to give you B. Class, I hope this was helpful for you all. I hope you can reference this as you go through these modules, and good luck with the module. As always, I'll be there for questions, and Teams me anytime you want. Thanks, guys.